my learners. How are you? How are you doing? It's me, Mourad Sultan Ezouidi, the pioneers in methods. Before starting, I'm going to share first the presentation. Okay, I'll go to YouTube first to share this on Facebook. Okay, this is my channel. Okay, live. What is that? Live. This one, yes. So I'll make like that. I'll make you share on Facebook. Okay, Facebook. On Facebook, okay, just one moment. Okay, so, okay, I'll post it. Hello, everybody. How are you? How are you doing? It's me, Mourad Sultan Ezouidi, the pioneers in methods, the Tunisian mathematical teacher that invents so many theorems, and I published so many books, and I already printed all of them. Okay, your booklet of 49 uh, volume of books in mathematics. And just I'm going also to start introducing who am I and whose theorem is. Okay, so we can say that first of all, learners, how are you? How are you doing? It's me, Mourad Sultan Ezouidi, the pioneers in methods. You can see this is my book, okay, solving 17th degree from equation, and also this is another book solving 18th degree from equation, 18th degree from equation, front back, and the cover. This is the cover, and also here another book deals with 17th degree from equation solved by Mr. Mourad Sultan Ezouidi. So I'm Professor Mourad Sultan Ezouidi, a mathematician, researcher, and author dedicated to uncovering the true nature of polynomial equations, a field that has challenged mathematicians for centuries. For a long time, my learners, the mathematical world has accepted the belief shaped by Abel's and Galois theorems that polynomial equation of the fifth degree and higher can be solved in a radical. This statement, in fact, became a cornerstone of classical algebra, a conclusion that discards exploration and closes the door to the new discoveries. However, as Professor Mourad Sultan Ezouidi, I refuse to accept this limitation. I will never hesitate to raise my hand and ask the question, and never accept these limitations of Abel's and Galois theorems. Okay, I have always believed that mathematics should not be found by historical assumption, especially when logic, structure, and symbolic reasoning can lead us farther and farther. Through years of research, study, and analytical refinement, I developed what is known now as Ezouidi theorem, what's known as EMST. E refers to Ezouidi, M refers to Murad, and S refers to Sultan, and T refers to the theorem of Mr. Sultan Ezouidi, a revolutionary method that unlocks exact symbolic solution for high degree polynomial equations, unlike, in fact, modern classical methods that rely on approximation, numerical iteration, or reduction to insoluble forms. My theorem, that is labeled as Ezouidi theorem, works through recursive symbolic structures and discriminant transformation, leading directly to precise algebraic roots. Means here we'll never give guesswork, we'll never make approximation, we'll give exact roots as it is. Okay, and written as a radical, okay, an exponential form. So leading directly to precise algebraic roots. It exposes the weakness of the so-called impossibility results of classical mathematics, and shows that Abel's conclusion was based not on absolute mathematical truth, but on methodological limitation. So, through my theorem, I have successfully solved fifth degree. Okay, and I have also successfully solved sixth degree, and I have successfully solved seventh degree, ninth degree, 10th degree, 11th degree, and 12th degree polynomial equation and beyond. Let's say 13 degree polynomial equation, 14 degree polynomial equation, 16, 18, 17, 19. Okay, I stopped at 19 and I'm going to planify for preparing a book of mathematical books that deals with 20 and 21st, 22nd, 23rd, and so on degree from the equation. So each solution, in fact, my learners stands as a clear demonstration that classical methods were incomplete and often misleading. Where classical theory fails to reach symbol closure, Ezouidi method provides a full analytic path, one that remains exact, verifiable, and elegant. Over the years here, I have published several books that document these breakthroughs, each representing a chapter in my mathematical journey. For example, this one, solving or mastering the solution of nth degree polynomial equation, in fact, represents a chapter in my mathematical journey. Mastering the solution of 10th degree from the equation, mastering the resolution of uh, 9th, 8th, and 7th degree from the equation, solving also, these are the couple of my books that I published and I invented, okay? Mastering we call the resolution of 6th degree, 5th degree from the equation using Ezouidi theorem. So Ezouidi solution for the fourth degree from the equation beyond the classical method. Here we will invent a new method, new theorem, a new framework that helps you professors and learners to guess let's not to guess, to give the exact sample proofs of this nth degree from the equation. Exact solution for seventh degree from the equation. And he also another book that is written in Dutch edition deals with fifth degree polynomial equation, also method, the resolution of the polynomial degree, and French edition. So each of these works challenges the foundation of classical algebra and presents clear verifiable examples that demonstrate the power of symbolic reasoning beyond approximation. Recently, I received a wonderful news. Let's say today, I received a wonderful news from Bookmendo website. Okay, that's settled in German. Some of my books have been sold in Germany. Yes, this is a fact. Some of my books have been sold in Germany, making a major milestone in my academic journey. I will soon receive my royalties, a symbolic recognition that my work is being read, studied, and appreciated by an international audience. This achievement is not merely about sales, it represents the growing acknowledgement of a new mathematical vision, one that dares to question old dogma and open door to exactness where others saw impossibility, like Abel theorem, like Galois theorem, that close the door. Mr. Mourad Sultan Ezouidi, the pioneers in methods, the Tunisian, opened this door, okay, and redefine a new algebra, new fundamental algebra. So we can say that one that dares to question all dogmas and open doors to exactness where others saw impossibility. My mission continues to prove that the so-called impossibility of solving high-degree equation is not a truth, but it's a historical error, and to inspire new generation of mathematicians to rediscover the beauty of pure symbolic mathematics. Through the Ezouidi theorem, I have shown that mathematics still holds secrets beyond the boundaries drawn by classical minds. in that the pursuit of truth guided by logic and creativity, and always rewrite the limits of what we once thought impossible. Okay, so I will just add something here. For over 2 centuries, mathematicians have pursued the universal solution of polynomial equation. From the ancient quadratic formula to the works of Cardano and Ferrari, every generation advanced one step closer to generality until Niels Henrik Abel and Evarist Galois in the early 19th century established a theorem that appears to close the path entirely. Means the door had been closed by these three scientists, man. So the result now, as the Abel-Zarafini theorem asserts that there is no general algebraic solution in radical for equation of degree 5 or higher. And here we are not talking about a second degree or third degree or a fourth. We are talking about mastering the resolution of 18th degree polynomial equation. And here also we are dealing with solving 17th degree polynomial equation. Each book consists of more than 200 examples of 17th degree polynomial equation with the whole or the full demonstration that will lead you to the exactness, to the to the uh, to the exact roots. Okay. Also, this book, okay, also consists of more than 200 examples dealing with 17-degree polynomial equation. The title was solving 17-degree polynomial equation using EMST. EMST. Okay. So we can say that, my learners, uh, this statement reshaped algebra, leading to the rise of group theory and field theory, and was long considered the ultimate boundary of symbolic solvability. However, this limitation applies only to the classical notation of algebraic resolution within the framework of Galois groups and traditional radicals. It does not forbid the discovery of alternative algebraic structure capable of producing exact solutions through new transformation and symbolic frameworks. The Ezouidi theorem means my theorem, okay, my pathway, my approach, developed by me, by Professor Mourad Sultan Ezouidi, introduced precisely such a new structure, universal symbolic and recursive method that determines the exact roots of polynomial equation of degree of any degree, in fact, of degree 3, 4, 5, 6, 7, 8, degree 9, 10th degree, 11th degree, 12th degree, 13th degree, 14th degree, and beyond. This theorem transcends classical constraints by expressing roots in terms of recursive algebraic invariants and symbolic discriminant structures, yielding exact solutions that can be verified by direct substitution. This is the power. This is the secret. This is the pathway. It's a new pathway. How this pathway or this method or this approach or this theorem will change 100% your thoughts, okay? The way you are thinking. Because when you are talking about 17th degree form equation, means you have a 17th relationship, okay, between the coefficient and between the new coefficient of the new 17th degree polynomial equation. Okay, so the foundation of the Ezouidi theorem here established a recursive algebraic framework in which the coefficients of pair of x are transformed into new structure sequences of quantities. Just I'll see if I'm still live or okay. Just a moment. Just a moment. So here we can say I will check if I am live or not. Okay. Where is it? Where is it? I already published it. Where is it? Here. Let's see. Oh, okay. I published it. Where is it? Just I will see the live, then I will come back. Record this one, isn't it? Okay. Yeah. So we can say that here in this introduction, this let's say we call that in which the coefficient of p of x are transformed into new structured sequences of quantities defined by symbolic and combinatorial relationship involving binomial coefficient and discriminant operators. This transformation revealed the hidden symmetry within the polynomial. Through them, the problem of solving p of x equals 0 reduces to determining symbolic expression that can be expressed through root extractions, recursive recurrence, and exact algebraic composition. The essential procedure of a Zweide theorem involves normalization of the polynomial and elimination of unnecessary intermediate terms through variable substitution. Let's say computation of the discriminant like coefficient, which encode the internal structure of the polynomial. Recursive calculation of symbolic parameters using Zweide recurrence relationship. Also, symbolic roots extraction, producing closed form algebraic expression involving a radical and exponential form. Verification of each root by direct substitution, confirming exact equality with the original polynomial. Through this method, through this method that had been published and had been written in my books that I published, uh, the theorem constructs exact algebraic roots for polynomial of any order, fifth, sixth, seventh, 10th, 12th, and 18th, and beyond, where a classical method failed to do too. Okay, so thank you for listening and see you next time. Goodbye. Goodbye. I will stop now. This one big, this one big. Mhm. Yes. End stream and goodbye.